Hello everybody, my name is Chris Brady, author of the Boeing 737 Tech Guide and the Boeing 737 Tech Site. And this presentation is about the 737 lights. So this will be covering external lights, those operated from the flight deck, then the other external lights which aren't operated from the flight deck, they're the service compartment lighting, which will probably be new to the pilots of the existence of these. Flight deck lighting, and then on from the flight deck, sort of electrical power, light testing, replacing bulbs, and application of the MEL. Then into the back for cabin lighting, emergency lighting, and finally look at the location of the various circuit breakers for all of the lighting systems of the aircraft. As always, please treat your company training and their manuals as the authoritative source of information. Okay, so for external lighting operated from the flight deck, we're going to start with the left-hand side of the external light switches. In other words, these here that you see on the right-hand three photos. Three photos because these light switches have changed over the years, you know, over the various generations of the 737. The top photos, originals and classics. The center one is NG's pre-2015, and then NG's and Max post-2015. So as you can see, the basic sort of layouts change little, but interesting sort of historical fact: the shape of those landing lights actually dates back from the 707, and they are ergonomically designed to look like lights in the same way that the landing gear lever is round to look like a wheel. The flap lever looks like a flap, and so on and so forth. These are designed to look like lights. Where there are four switches, which is basically all 737s pre-2015, you've got a spring-loaded gang bar above the switches, and the purpose of that is so that all four switches can be selected on immediately and simultaneously. The logic, I believe, is when you're breaking out a cloud near minimums. So if you don't want to be distracted by having the light on when you're in cloud, as soon as you pop out of the cloud, you can just hit that gang bar, all four lights come on, and you've you can illuminate the runway. There is a theory doing the rounds. If you look on the top one, that most of these gang bars are slightly sloped, and the theory is that brings on, or just puts a slight delay between switching each one on. But personally, I'm not so sure about that, but the idea is that reduces load. So, starting with the fixed landing lights, or inboard landing lights, as they were known, they're always in the wing route. There is an option for alternating pulsed fixed landing lights for extra conspicuity. As you can see on this photo here, it's labelled up as pulse, usually only seen as options on the BBJs. On the Max, they've relabeled it as flash rather than pulse, but it works in exactly the same way. This is more in the realms of biz jets, which is why I guess the BBJs have it. The landing light switches, we've already mentioned these four on the end with the gang bar. But the outboard and retractable landing light switches, they're actually three positions. So off, extended and off, and extended and on. So off and on are fairly self-explanatory, but the purpose of the extended but off position is to actually pre-move the light into a position so that they can be switched on instantly to illuminate the landing area. And why you would do that rather than not just put them straight to on from off is because the lights have to physically move, from a retracted position to an extended position. And if you do that with them on, what you get, and this can be quite disorientating, is you get the lights initially shining below you as they come on, and then gradually they move forward to shining in front of you, and that movement can be quite disorientating. And I presume way back in the annals of history, some poor crews got disorientated by that, and it may have led to, you know, an incident, if not an accident. I can't actually find a particular accident associated with that, but I can speak from personal experience that it can, under certain circumstances with certain cloud cover, be quite disorientating. So that's the logic for having the extender but off center position. The originals and classics had outboard landing lights. They were mounted on the outboard flap track fairing, and hence they were labelled outboard. With the NG, the outboard landing lights were moved under the fuselage, and in that new position they were actually no longer outboard, so they had to be renamed, but they were still retractable, so they adopted that name of retractable lights, as opposed to the fixed lights. Pre-2015, the landing turn off and also the taxi lights were these very large halogen PAR lamps, or parabolic aluminized reflector lamps, and these things are massive. The standard sizes were either 300 or 450 watts, and they had a very short lamp life of around about 70 operational hours. So they were big and expensive, and not particularly robust or durable. One of the methods of increasing high wattage bulb life is actually to step down the voltage from 115 volts AC, you know, at the main transfer buses, down to 28 volts AC, and running the bulb at the low voltage means that a thicker filament could be used, which has got a longer life because the resistance is lower for the same current. So a bit of sort of, you know, basic electric-y physics there, but it does work, and that's why the voltage is often stepped down at these larger lights. You can just see the transformer in the top photo. You can't quite see it in the bottom photo, but just, you know, because I have the space, showing you there a light that looks rather like an eye. That center part being a black discoloration of the lens. So that light, if it hasn't already gone, is probably about to go. In 2015, the retractable landing lights were removed completely, and all landing lights and taxi lights were housed in the wing roots. As the retractables are gone, the 4 switches were replaced by simply 2, and simplistically named landing light switches. Now, these new combined landing, taxi and runway turn-off lights, known as LTRLs, and 4 modes of operation, as you can see there: off, taxi lights, turn-off lights, which you can't quite see in this picture, but they are pointing outboard by, I think it's about 30 or 45 degrees, can't remember exactly. And the landing lights there facing full forward. So, but basically the taxi lights are just like a lower intensity version of the landing lights. The other difference with the LTRTL lights is that they were changed to LEDs as opposed to the halogen PARs. Now, LEDs, as you know, you probably know from, you know, your car or your house these days, they've been around for 10 years or more in common usage, you know, for 10 years or more. They've got the same advantages in the aircraft as they have, you know, in your car and in your house. They're much brighter, much less electrical consumption. You know, lower power for the same luminosity. They got significantly longer lamp life. These ones here are quoted as around 10,000 operational hours. And in the official blurb from Boeing, it said they've been designed to last the life of the airplane. Why on earth they've used that as a figure when they're quoting them as 10,000 operational hours, I don't know, because most aircraft exceed 30,000 hours, and I've flown a few which have exceeded 60,000 hours. Anyway, whatever. It's way longer than the typical 70 hours of the old halogen PARs. So the unit gives savings in both replacement bulb costs and engineering time to do said replacements. Earlier this year, the original 2015 units manufactured by Cree being replaced by Osram units due to LED browning and discoloring. So there's obviously still a little bit of ways to go for maturity of these new things. Taxi lights. These were on the nose gear right from the beginning of the 737 in '67 right through until 2015 with the LTRTLs. Again, these were huge bulbs, either 250 or 450 watts typically. And I say these were moved into the wing route as part of the LTRTL upgrade. Reasons quoted for moving the taxi lights were cost reduction by combining that unit with other lights, weight and drag saving because you've no longer got to have that nose unit installation there. Reliability, because the light on the nose gear was exposed to significant shock and vibration loads, depending how sweet your landing was. And reliability, as the nose landing gear is exposed to more FOD and tow bar damage. And again, I've had one or two of these smash when the tow bars have been connected, disconnected, or a shear pin break. And that's what the new nose gear leg looks like with it without the taxi light. As we know, this change is not universally popular with pilots. Because the new location of the taxi lights in the wing route actually casts a shadow directly ahead, or at least the fuselage casts the shadow directly ahead, because that's in front of the light. So it can make it difficult to see taxiway markings, particularly at night in the wet. Sometimes you can find it helpful to supplement the taxi lights with the turn-off lights. But there we go. The auto position, for what it's worth, this is an option. Some of you may just have on-off lights, some may have off auto lights, and this is the same logic depending whether if the taxi light's mounted on the nose gear or in the wing route. It's the same logic for both, but when the nose landing gear retracts, the taxi lights automatically switch off, and they'll come back on again when the gear is fully extended and locked. So on the right hand side, we've got logo strobe position, anti-cold wing and wheel well on most aircraft. I say on the classics, this particular one, the strobe and position lights were combined. And on the originals, well, some originals, this one had the unpaved strip kit or the gravel kit, whatever you call it. You got the gravel protect switch there, which has nothing to do with any lights. If you want to see more about that, see my gravel runway kit video for that. Other thing to note is that early originals, as you can see on the bottom there, didn't have strobe lights. They weren't out yet. It was all done on the anti-cols. I think the only other thing to mention is that the military 737s, particularly the P8s, don't have a logo light. I mean, why would they? Okay, so logo lights. Let's talk about those. On the originals and the early classics, that's what you used to see out on the wingtip. There was this bulbous fairing on each side, and that was purely to house the logo light. I mean, it also housed the aft position light, as you can see there on the left, but it didn't need to be that size and for just the aft position light. So that was to hold that. Now you can see a host of screws around there. I mean, counting up, it looks like what, 5 either side, so there's 10 there. Now some of those are to secure the unit to the wing tip. So you would take some of those off to replace the bulb. The others are adjustment screws to ensure that the beam's pointing directly toward the center of the vertical fin. So you get your advertising on your logo, which is what the whole thing's for. Sort of midway through the life of the Classics, the logo lights were moved to the top of each horizontal stab, which is where they are now. Right the way through to the Max. You can just about see them here in this photo. It's kind of hard to get a photo of the light and the it's shining on the fin, but that's where they are. So they're about 2/3, 3/4 of the way outboard of each horizontal stab. That's what they look like from the rear passenger door, and you can see that these logo lights, they're completely flush with the stab surface now to reduce drag. That's the whole point. And the bulbs are now halogen or LED these days. The only disadvantage of this, I mean, obviously you've got a huge advantage in drag saving. Disadvantage, for what it's worth, is that the beam moves slightly with the stab position. So obviously, as you've got a different stab toe, so the stab will move, and the light will either shine centrally on the fin or slightly forward or slightly aft. But anyway, there you go. Strobe lights, let's talk about those. As I've already mentioned, they weren't originally fitted to the 737. They basically it was all just done on anti-cols. They started to be introduced in the late 1970s, and they're now fitted as standard to the tail cone and both wingtips. These units are sort of rectangular shaped. You see it better on the bottom. Well, the top photo is a photo of a 737-200 without strobe, so it isn't there. But it is there on the bottom one, and some subsequent photos will show it a little bit better. But the rectangular shaped xenon arc flash tubes, and these make a very short but bright, very, very bright pulse of light when a capacitor is discharged through this inner xenon gas within the tube. Way more brighter than incandescent bulbs, and they've got a longer lifespan. The only drawback here is really they can't produce steady light. Hence, the use is limited to strobes and latterly anti-collision lights. Outside aviation, these are widely used as rechargeable flash bulbs for cameras. So if you've got a camera, then you'll see this trademark sort of rectangular shape, very bright light off it, but it's only for a fraction of a second. In 2012, Boeing changed the halogen position and xenon strobe winglet and tail strobe lights to LEDs. Like everything else, it's all moving towards LED. Again, listing benefits of LED over, well, specifically halogen and xenon. These are, as quoted from Boeing blurb, increases aircraft safety and recognition through improved light color output and uniformity. In other words, it's brighter. LED life up to 50,000 hours, which is a 10 times improvement over xenon. So that is significant, and that is rocking on toward the lifetime of the aircraft. Weight reduction, yeah, apparently they're lighter. The input power is reduced by over 50%, which obviously is always good news. No scheduled maintenance required. With a 50,000 hour life, you wouldn't think there would be. And it reduces operator costs through reduction in maintenance and improvement in aircraft availability, as you would expect. And you can see what the LED one looks like on the bottom photo there. Now, Interesting sort of fact of when strobes were well, sorry, not when strobes were first fitted, when winglets were first fitted to 7.3s with strobes, as of course they all did at the time. The single leading edge lens which housed both the position and the strobe light units, the one in the top photo, was retained from non-winglet aircraft, but reshaped for the winglet. So in other words, it was curved slightly up. But again, there was one lens in it, and it housed both the position light and the strobe. Unfortunately, what they found in the early years of operation was because this strobe actually shone further forward than a non-winglet lens, a large light fence had to be fitted to avoid the more forward-facing strobe light dazzling the pilots. And you can see it in the photo. It's a real big fence, and in fact the fence was actually so significant that the SMID had to be reprogrammed and updated for the aerodynamic effect of that fence, because obviously it's got an aerodynamic property as well as a light shielding property as well. So they had a little rethink, and what they did was they divided the lens into two units, as you can see on the bottom photo. So they separated out the strobe from the position light, and located the strobe light further aft, to reduce the forward dazzling. Now there is still a small light fence there, but it is very, very small by comparison with the other one for sure. But basically it's the size of a small Vortelon. And with that, no SMID update is necessary, because the aerodynamic effect is so insignificant. So that was done, and most of the aircraft you'll see will have these dual lens lights. But if you ever fly any early ones, you might still see the single lens lights there. Tail strobes. Basically, these are just a couple of pictures to show you what it looks like. The middle photo is what it looks like from the outside. That's what we see. So just above the APU, that's where the tail strobe is. The photo on the right is what it is the view from inside the APU tail cone. Not a view we often get, but you can see the sort of black plastic, sort of rounded rectangular unit, and on the left hand side, that's what it looks like. That's just basically from Honeywell's website, and that's the new LED strobe module, and that was built to that size and shape to be completely interchangeable with the old xenon flashing strobe. So these days, you know, all new aircraft are being manufactured with LED ones. And most airlines are replacing their old xenon ones with LEDs on an attritional basis. So as the old one breaks, replace it with one of these. The Max, slightly different arrangement. As we know, it's actually got two rear white position and LED strobe lights, and that's simply because of the tail cone geometry. There is nowhere to put just one light that would be effective, so we've got two, one on either side. Position lights, you can see a pair of white position lights there on that photo. Again, since 2013, same old story. Halogen position and xenon anticols were upgraded to the lighter, more efficient, longer lasting LEDs. That's a little close-up photo there. Again, you can see the dual lens arrangement. You can see the Vortelon there, just in front of the strobe that I was talking about a couple of slides ago, just to help with dazzling, the slight aerodynamic benefit as well. But the position lights are what this photo is about, and you can see that there, it looks like 8 small LEDs there. In 2 units, so much more reliable, much brighter, and if any one of those 8 were to fail, you can still dispatch Whereas if it's a single bulb and that fails, then you're limited to day operations. The left and right position lights, they're always on the forward edge of the wingtips, and that's on every generation of the 737 from originals through to Max, as you can see here. The aft position are, well, again, I've got 4 photos here showing the position. So top left is originals and early classics. That's with the bulbous arrangement, which houses the logo light. Midway through the life of the classics, the logo light was moved to the stab, so you've got that slender tube for the aft position light. On the NG, they changed it to a double light just for reliability and dispatch reasons. So again, if one fails, you've got another one as a backup. And on the Max, because you've got these AT winglets, they couldn't really house it there, so it's gone onto the tail cone. That's the only generation where it isn't on the wingtip. Now the Max has also got these. They're known as aft marker lights. Now these not to be confused with the aft position lights, and you can just about see it in the larger photo. The angle it's designed to be seen is below. So it's a downward facing white light on each lower winglet, and it's described in the Boeing literature as to assist service personnel during ground operations. What it really is to warn ground crew that the winglet's there to stop them from driving into it. That's what that's all about. It's a don't hit me light, I guess. Anti-cols. Talking of don't hit me, there's one anti-col on the upper fuselage and another one on the lower fuselage, so 2 in total. As part of the performance improvement package, again see separate video on that, from March 2011 onwards, both of these lights were changed from the old cylindrical shape, which you see on the top photo, to an oval shape for drag reduction measures. On the upper anti-col only, the upper skin was revised and some strengthening put in there to reduce the risk of crack mitigation, because you've got a shape which is no longer circular. There's more chance of a crack forming and propagating. Because of that structural change, no retrofit is possible. So you can retrofit the lower anti-col if you wish for drag reduction, but you can never retrofit the upper one because of the structural work that needs doing. So there you go. That's an easy way to identify if an NG was built before or after 2011, is look at the upper anti-col, and if it's round, it's pre-2011. If it's oval shaped, it's post-2011. Fun fact, the anti-col on the top of the fuselage can be replaced from inside the aircraft. There you go, done within the cabin. The 73s with the optional unpaved strip kit had a retractable lower anti-col to prevent it from getting damaged on landing, and you can see the switch there on the only example of this type I ever operated. And there's an AFM limitation for its use as follows: do not use the retractor position of the light switch except to protect the retractable anti-col light during landing. In other words, it's only to be used for landing on gravel. Those aircraft also had a mesh guard on the forward-facing side to protect it against debris thrown up from the nose wheel, which you can see there. Okay, back onto present-day aircraft. Well, almost. This is an NG. Wing lights used to check the leading edges of the wing for ice accumulation. Is the main use, and again these can be normal lights or LEDs these days. Normal lights use 115 volts AC. LEDs use a fixed step-down transformer in the actual light assembly itself to decrease the voltage down to 12 volts. Wheel well lights. So there are three of these in the, or three dome lights in the main wheel well. On the originals and classics, it's just two. There's one in the centre of the ceiling, one on the forward starboard wall just above the flap transmission shaft, if you look back for that, and one on the aft wall. And these are for crew use when checking the wheel well on a pre-flight external inspection. Also for engineers when working in the wheel well. Now the dome lights may be in-op in accordance with the MEL, as you can see up there in the MEL extract. 3 installed, none required. There you go. But in addition to dome lights, you've got 2 inspection lights. Now this photo, as you can see, because we've got a downlock viewer, this is on, well, this one's actually from a classic, but it was the same with the original as well. So for the originals and the classics, you've got 2 inspection lights, and these are to illuminate the gear downlock indicators in flight. If you're unsure whether the gear's down and locked, you put the wheel well lights on, go down the cabin, lift the section of carpet over the wing, look down the periscope, and you can check the downlock viewers. Now, again, I've got photos of this in the landing gear video if you want to see that. But unlike the dome lights, the inspection lights are mandatory for night operations, unless you've got an alternate landing gear indication system installed. And freighters often have this. And again, refer back to the freighter video for that, where obviously freighter crew can't access the center of the cabin because it's loaded with pallets, so they've got an alternate landing gear indication system. It's basically another set of green lights, for the gear being down and locked. But if you haven't got those, if you're on a regular passenger aircraft, on original or classic, these inspection lights are mandatory, and you can see the MEL extract that they are required. Therefore, you should consider putting them on when you do a pre-flight external inspection to check that the lights are working, particularly at night. Now, surprisingly, there are also inspection lights on the NGs and the Maxes, even though they don't have gear downlock viewers. However, they're not mandatory under the MEL. And this is a photo from is that a Max or an NG? I think it's a Max. But you can actually see the decal there actually says main landing gear inspection light. So they are still present, but not required under the MEL. The nose wheel well has a light as well, just one, and it's on the forward bulkhead. You can switch it on either at the external power receptacle or from the flight deck. And just a word about wheel well light switching. The switch on the external power receptacle panel only operates the nose wheel light, not the main wheel well lights. Similarly, the switch in the main wheel well only switches the main wheel well light, not the nose wheel well light. The only switch which does both mains and nose wheel lights is the one in the flight deck. And just to sort of finish the point on this, that the flight deck switch was put there to enable crew to inspect the gear downlocks in flight. But with the removal of the viewers from the NG onwards, I for one am surprised that this switch hasn't been removed, because it's kind of redundant. You don't need it in flight on the NG and the Max because you haven't got the viewers, and on the ground you can just switch the lights on individually at source with those 2 switches you see there in the wheel well and the external power receptacle. Anyway, it's still there. They've obviously forgotten about it. Okay, service compartment lights. Engineers become familiar with these, pilots less so. In eBay, start there. There are 4 lights in there. Well, actually, it depends whether we're talking about NGs and Maxes or classics and originals, but 4 lights on the modern variants. The switches on the service panel, which you can see on the original and classics on the upper photo, and on the NG and the Max on the lower photo. So it's just a push button switch on the NG and the Max. In the forward equipment bay, there's 3 lights up there and a single light switch which is just under the weather radar rack. So as you pop your head in the hatch, look forward, the switch is just there on the left if you're facing forward. The aft accessory compartment, so that's the stab jack screw there in the photo, and marked in the red box is the light. So there are 2 of these, one on each side, you know, the sort of port and starboard side of the aircraft, and the switch is actually next to the access door. So the switch is logically by the door. You press that as you go in, and it gives you 2 lights up there. The tail cone compartment, which is further back from the aft accessory, that's just got 1 light. Again, light control switch is inside the tail cone compartment, forward of the access panel in the lower right corner. And again, I've put a photo in there so you can see where that is. The APU compartment has got 2 lights shown there on the right hand photo, and a little enlargement of one, and the switch is on the forward bulkhead next to the light there. So you can see the switch marked S00086 there, so it's just by that switch. And the air conditioning compartment, so you've got floodlights in both left and right aircon compartments. And there's also a floodlight between the 2 compartments as well, and you can see the lights on there in that photo. Toggle switch on in each compartment to operate the floodlights in that compartment. Either toggle switch will also operate the center floodlight as well. And the cargo holes. These lights are only on when the cargo compartment door is open and the lighting switch is in the on position. If you close the cargo compartment door, the lights go off automatically. If the door's open, you can push the lighting switch to the off position to make the lights go off manually. But the normal operation is it's automatic. Door opens, lights come on. Door closes, lights go off. This switch really just gives you the option to have the light switches off with the door open. The refueling panel's got a light as well, and this, unlike all the other light switches, or all the other lights, sorry, doesn't have a, I was going to say doesn't have a switch. It does have a switch. It's a reed switch, so it comes on automatically when the refueling hatch is opened. So there's no switch that you can switch on and off. As I say, it's done automatically. Reed switch, for those who don't know, it's a magnetic switch. So it's a pair of ferromagnetic flexible metal contacts in a glass envelope. The contacts close when brought near a magnet, which in this case is on the door panel hinge. So so that, you know, just handy for the refueler. As soon as he opens the hatch, the light comes on. Okay, let's take a look at flight deck lighting now. There's an awful lot of this, as we know, but let's take you through the various bits. So there are 2 dome lights, one behind each pilot. Powers the dome lights from the 28-volt DC battery bus, so you should always have power for these lights, you know, as long as you got a battery. Dome light switch we know about, dim, off and bright. Now the captain's dome light, just above the P18 panel there, that's also part of the emergency lighting system, and so there are 2 bulbs in there. One is for the normal use, you know, the dim, bright, you know, from the dome light switch. The other one will only come on with the emergency lights. So if you switch the emergency lighting system on, you will see that light come on. So yeah, try it next time you're in the flight deck, you know, on the ground. Just have a play with these light switches, and you will see the different lights there. Other lights we can find there, the flight kit light, or as I always know them, the wander light, because you can detach it and sort of wander around with it, bit like a torch. They're located down by our flight bags. Brightness controlled by rotating the rear bezel. If you rotate the front bezel, then it'll change from the light will change from white to red. The logic being that red will preserve your night vision. The observer's reading light, again, it's a wonder light for the observer. Officially known as the observer reading light or the utility light, and it's in that alcove just above and forward of the data loader. Note that there's a spare socket for, or an extra socket for it, just above the jump seat stowage, which you can see there in the second photo. Chart lights. So this, well, the photo on the right, if I explain it, it's taken looking upwards. So kind of from your left armrest looking up, and you can see the light there hidden behind a shroud. That's to avoid the light shining in our eyes, because it's quite near our eyes. It then reflects from that mirror down toward the chart holder on the side window. So that's how that works. And there's a little adjustment screw there, which you can see sticking out, just to adjust the angle of the mirror in case it no longer shines at the chart. The map light, which is just forward of the chart light there, these can be pointed wherever you want them. So the chart light purely focuses at where the chart stowage is. The map light can be pointed anywhere you like. So you can have it on the yoke, you can have it on your lap at the tech log. You can move that around as and where you need it. You can widen or narrow the beam by rotating the lens, and you can see left and right photos there of narrow and wide beam. The location of the map and chart lights are slightly different from the FO side to the captain side, which I've tried to sort of get with these two photos here. And that, I mean, I've never seen this written down, but I believe it's to accommodate a hood on the captain side if required, because that void where the lights are located on the FO side, on the captain side, is where the hood is located. So that's my logic, for my theory for why it's in a slightly different place. The circuit breaker panel has got its own illumination. There are 5 CB panel lights, 2 for the P18 panel and 3 for the larger P6 panel, and they're located on the floor and the sidewall. The sidewall that I've shown there, and also on the ceiling as well. All 5 are controlled by a single rotary knob on the forward overhead panel, and notice the decal on that light helpfully states which replacement bulb to use. So you've got an 1864 bulb written on there for changing them. The panel lights are I say these are the ones in front of the captain. The FO's got a controller for his own panel lights as well. So on there you've got the main panel background AFTS floodlights and DU brightness controls, all on the captain's side. The panel lights illuminate the individual instruments and the light plates. So you can see just in that little inset photo up at the top right, some lighting coming down from that's the standby RDMI, illuminating that individual instrument. Background lights, these are strip floodlights made of several incandescent bulbs. So you can see off on the upper picture, on the lower picture, and you can actually see the bulbs in there. You got, let's see, what's that, 5, 6, 7, 8 bulbs shining through, where it's slightly more bright than the other areas. The AFTS floodlights, very similar arrangement, also strip floodlights. The electrical panel, the control for that is the inboard one of the pair, the sort of back left of the panel, label panel, and that controls both the light plates and the LCD brightness. So again, you can see, off and fully bright on the right. There is a floodlight as well, which is located in the overhead panel. This shines down to floodlight the electrical panel for you. So it's perhaps a bit confusing at first that the control is on one panel for a light which is on another panel, but it's shining down towards the the electrical panel. Now all panels have got a light plate over them, which you can see here in this dark photo. They contain internal lighting, and the light plate is coated with an opaque paint, and the lettering and any other markings on them are etched into the paint, so the internal light shines through. This photo is a favourite of mine because it shows the electrical panel floodlight looking just like a nice pint of Guinness, just to tempt us while we're on long flight. But there you have it. Now going back to the light plate again, a common question I'm asked is what is this little cross which is on each panel? Strictly speaking, the cross is actually on the light plate, not the panel, as you can see in the upper photo, and every light plate has got one. And if you remove the light plate, as shown on the bottom photo, it shows where the electrical connection is for the lighting behind the plate. So if a light plate isn't illuminating correctly, if you push or press on the light plate at the plus sign, it might help make the electrical connection between the light plate and the panel. So that's the mystery of the cross solved for those that were curious. Now, one more thing to say about light plates, and this was a photo I took a few years ago of a light plate that wasn't correctly seated. So care should be taken. This is obviously to engineers, not to us as pilots, when screwing the light plate back onto the panel, that the electrical connection pin is fully home. If it isn't, then that pin will impinge on the panel behind it, and not go into where it's seating. Now, not only will that light plate not illuminate, but it'll also distort as well, and could lead to a failure of the panel. Certainly, failure of the pin on the light plate behind it. So something to look out for. If a particular light plate isn't illuminating, some things to try. Press on the cross and just look and see if the light plate's been mounted correctly. DUs, they've all got their own brightness controls, and each DU has got a light sensor on down at the bottom left, except for that lower DU, which is on the upper right, because the thing is mounted upside down. And these just adjust the display brightness to the ambient light conditions. So you set a brightness with your controls. It fine tunes and finesses it with the ambient light sensor. The ISFD, similar arrangement. Like the DUs, they got their own brightness controls on the left hand side there with the plus minus buttons. There's also a light sensor, which is that small sensor on the top right there, that adjusts the brightness to the ambient light conditions. The standby compass, this has got a 3-position dim, off and bright switch. Power to this light is from the 28 volt DC battery bus, so you should have illumination for this even on battery power. Considered one of the most essential instruments on the flight deck. If everything else stops working, you've still got a magnetic compass to navigate by. Wouldn't like to do it, but there you have it. Another fun fact: the bulb in the standby magnetic compass here is a special non-magnetic bulb, so that it doesn't affect the compass readings when you switch it on. There you go. Okay, let's have a look at the electrical power light testing, replacing bulbs, and the MEL. So we'll start with electrical power. This schematic here, a little extract from the electrical videos, ones I did, what you can see from this is that most instrument lighting is normally powered from the 28 volt AC transfer buses 1 or 2, and step down through a transformer to 5 volts. Certainly in the Flightdeck, it's 5 volt lighting. Some background flood lighting is 115 volt. It's from 115 volt AC transfer buses 1 or 2. Instruments that are necessary for flight safety, so your essential stuff, your instrument lighting, will connect automatically to the standby light system in the event of a transfer bus failure, and that's shown here on the AC standby bus 2. If normal power is lost, relays connect the 28 volt AC standby bus to any necessary standby transformers to give 5 volt AC for the standby instrument lighting. So you've got a normal power source and a standby power source as well. Light testing. Most bulbs in the Flightdeck, wait to see if they're working is by putting the master light test and dim switch to test. This illuminates all system lights on the forward and aft overhead panels, and some lights on the captain's and FO's instrument panels to full brightness. So you can see there at a glance. Should be done in your preliminary pre-flight checks, just to check that all bulbs are serviceable. And prize for anybody can see the bulb which is in op on that lot. If not, I'll come on to it in a moment. Now, most enunciator bulbs can also be tested by pushing them. Exceptions for those include ones where pushing them has got a specific function, such as below glide slope, because you've got to push to inhibit on that. The autopilot and auto throttle indicators, which have got their own dedicated push to test switch, and the cargo firearm switches and discharge switch, and master caution and fire warning. So they are on a separate system. If any bulbs require replacing, there's a spare bulb pack in the ceiling above the FO's seat. I'm sure we've all seen it. Don't know how many of you have actually looked in it or used it. The composition of the spare bulb pack has changed slightly over the generations. The photo on the right is of a classic, and a lot more bulbs in there than the photo on the left, which is of a Max, and that is fully stocked. I'm not sure why there's so few 387s in there, but anyway, there we go. And that's just a reflection of the changing number and type of bulbs to be found on the aircraft. Replacing bulbs. So let's have a word about this. Now, as previously mentioned, some lights helpfully have a decal on them stating which type of replacement bulb should be used, and you know, going back to the circuit breaker area illumination light, it actually says on 1864 bulb, and on you can see in the photo there, that is an 1864 bulb, and there'll be one of those in the spare bulb pack. Note that if you use a bulb with the wrong part number, so not an 1864 in this case, even if it fits, it might cause the associated circuit breaker to trip. So don't think, oh, there's no 1864s in the pack, I'll use this one. You might cause bad things to happen further downstream. The other thing I would say is, when changing a bulb, don't assume that you must replace it with one of the same part number as the bulb that you removed, because the last person may have used the wrong bulb. So if you take a bulb out of somewhere and it says on it, I don't know, 1864 or whatever it says on, don't assume that that is the correct bulb. Again, it's more for engineers, really. I mean, you know, as pilots we don't get involved in too much of this, but that's just a good rule of thumb to live by. Now, the only bulbs we as pilots would ever normally change are the 387s, which are used in the overhead panel enunciators, which are colloquially known as Corries, who are the manufacturer of these captions. Now, each enunciator has got 2 bulbs in it, but if one's failed, then the other should be replaced in case the other fails and a warning is missed. But it's got 2 basically to save us, you know, as pilots, from absolutely having to change a bulb if one goes. You know, you can just leave it till you get down and then tell an engineer. But obviously, if the second one were to go, I mean, what are the odds? But if the second one to go, you may miss a warning. I mean, the mast caution 6-pack had still come on, but well, depending what it was, if it was an amber. But these, you know, these may not. Now, some engineers like to replace both if one's blown, as they'll tell you that the other one often fails when you put a new bulb in, which you know, which can happen. But what I would say is that, you know, to us as pilots, just be aware that it can be difficult to remove these enunciators from the panel, and you can end up accidentally, and I've done this, I speak from personal experience, put my hand up and say, you can accidentally end up pulling the caption plate off the enunciator. So in this particular example, you'll end up with a little plastic, thin plastic decal or whatever you want to call it, you know, a light cover which says spar valve closed, but you haven't got the whole unit out, which is the bit which has got the bulb in, and then, you know, that's that broken, and, you know, you kind of possibly AOG waiting for an engineer to find a spare one of those. So you can do more harm than good. These ones are actually easy to get because you can get your fingers on either side of them. All of those in that picture are easy, but some of the others where they're bunched, that's quite closely packed, it can be difficult to take them out. So I would say, if it's not easy to get, if you can't do it in a couple of seconds, then leave it for an engineer to do. This is their bread and butter, and he might even have a knacky little tool to get it out. Now the enunciators, again, these are the Corries. They are actually keyed. They're uniquely keyed. Every caption has got its own unique keying, and you can see from the decals on there that their own part number, and that prevents you I'll say accidentally, because who do this for a laugh, pull out a couple of captions and put them back in the wrong place. So this is designed to stop us from doing that. You know, if you were to, I don't know, try and change a couple of bulbs at once, you might, I guess, put them back in the wrong place. Well, the keying saves us from doing that. They won't go in the wrong hole, is what I'm saying. So they're pilot proof, which is good. We like that. Other bulbs definitely best left to the engineers to change. Things like this, the LED devices, bulbs. To change these bulbs, you'd have to unscrew the light plate, and then you would have to get a fine pair of pliers to pull out, you know, these particular bulbs and replace them. I wouldn't go anywhere near that with a big stick. That's definitely one for the engineers. But again, I include it in this presentation just to show you, you know, what it's like and what lies behind there. Notice again, just before I move on, the little cross on the light plate, just toward the lower left hand side. And you can see that with the light plate removed, that's where the electrical connector goes in that sort of large circular hole to illuminate the light plate for you at night. So legalities, all this talk of me saying, you know, you can change bulbs, but probably best not to. Can we do it in law? Well, the legal position in Europe, and this is AMC 145A.30, is that the commander may carry out replacement of internal lights, filaments and flash tubes. And that's it, and you can look up this reference for yourself. Typical tasks that may be certified and or carried out by the commander holding an ATPL or CPL are minor maintenance or simple checks included in the following list. Item A, replacement of internal lights, filaments and flash tubes. A flash tube, I don't think I'd do, but again, you know, this could be an easier job on a different type of aircraft. You know, we're talking about 737s. This rule here applies for all aircraft. So don't think, okay, the law says I can replace a flash tube, I'm going to have a go. There are definitely some jobs best left to engineers. Okay, let's see what the MEL says about it. It's actually not specific about what flight deck lighting is required. It simply says that remaining lighting system lights are sufficient to clearly illuminate all required instruments, controls, and other devices for which they are provided. So basically, it's down to you as the captain to assess this. If you're not happy with the lighting remaining, then the MEL is your friend, and if you wish, you can insist that it's it's fixed and repaired. It also says that individual button stroke switch lights and or annunciations indications are excluded from this relief. In other words, they must all be working. With external lights, the MEL generally allows individual lights to be in op if there are other lights available. For instance, strobes can be in op if the anti-cols are working. Some lights can be in op for day operations only, for instance landing lights and position lights. Generally, if a lens is broken, the MEL stipulates that the bulb must be removed before flight, unless it's part of an LED module where you've got multiple LEDs in there as backup, so that doesn't need to be done. That photo there is an example of a light I had break after a shear pin failure. I got out and took a quick photo of that. That obviously would need to be sorted out before flight. The CDL, unlike the MEL, it's only concerned with external lights that might have an effect on drag and hence fuel burn or performance limited weights. And the only lights really which could create any significant drag are the retractable landing lights. For those aircraft that have them, obviously, your pre-2015 aircraft. The fuel burn penalty is around 1% if the lights are extended in flight. All the other lights don't create any significant drag. However, the CDL does state for any light which is removed, cover the open hole with speed tape or similar temporary cover, such as a backing foam filler, in conjunction with speed tape. So, in other words, streamline them to reduce drag. Okay, on to cabin lights. Let's have a look at these. So the passenger compartment's got a mixture of fluorescent, incandescent and LED lights. It's got all kinds depending on where they are located and what they're doing. There's a table there which I won't bore you with. But let's have a look at the controls. So the lights are controlled from both the forward and the aft cabin attendant panels. And the photos here are showing each generation, Classics NGs and Sky Interior is applicable to both NG and Max. So for Classics and NGs, both panels can control the entry lighting, but only the forward station can control the ceiling and window lighting. But with the Sky Interior, there's a full control unit at both the forward and aft panels, so there's more control for the crew at the aft station. The forward cabin attendant panels I've shown here for each generation, and the Sky Interior lights are shown here. These were introduced in 2009, and according to Boeing, it was inspired by the extensive passenger research that created the 787 Dreamliner interior. It effectively integrates innovative architecture, lighting, and features that improve operation, maintenance, and passenger comfort. Well, there you go. Lots of words for new lighting. I think they're an improvement. I like them. I am a fan. I'm not sure I'd wax quite as lyrical as Boeing do, but there we go. And features you've got with this, you for the first time you've got colour lighting with LEDs, and it includes pre-programmed colour scenes, Previously, lighting was always white. You've got forward and aft LED cove lighting. You've got new sculpted sidewalls and colour LED sidewall lighting, and new PSUs, passenger service units, with the LED reading lights. So it was an improvement, thanks to the 787, I guess, but just trying to keep a pace. These are what the Sky Interior lights can look like. So the panel is touchscreen, lots of options on it for the main seating area and the forward and aft entry areas. Shown here, the upper photos are Rossa, which is by pink, and the lower one is a multicolored one called Brazil. So you got the red, green, and yellow there in play. Now notice that the upper display is the standard single zone control, because there are two options with Sky Interior Light. You can either have single zone control or two zone control. Obviously, there's a premium to be paid by the operator for the two zone control, but there it is shown on the lower photo. One interesting fact you may or may not be aware of: on Sky Interior cabins only, in the event of a rapid decompression or when a pilot selects the passenger oxygen switch to on, all of the lights in the passenger cabin entry and galley areas will automatically illuminate bright white. So it's a nice little safety feature just to cast some illumination on what's going on. I guess the assumption being that there's some situation broken out, and more importantly, that the passengers will appreciate having full illumination to don their oxygen masks. Cabin call lights. So the overhead exit signs have also got three small little lights in them for signalling where a call to cabin crew has come from. So from left to right, you've got the pink, which is from the flight deck or the flight attendant station. Blue in the middle, which is a passenger seat call switch. And on the right is the amber, which is a LAV call switch is activated. The LAV call light will also illuminate a light outside the LAV that the call came from, as you can see in the upper photo. The LAV lights, incidentally, are operated automatically from the door lock switch, so there's no light switch as you'd have in your LAV at home. It's all done by the door lock switch, so when somebody goes in and locks the door, the lights come on then. Okay, emergency lighting. Let's talk about this. As we know, by emergency lighting, we're talking not only of the exit signs, but the location signs and area lights, controlled by this 3-position on, armed, off switch in the flight deck. And point to note is that the guard of this switch is designed to move the switch to the arm position when it closes. So if the switch is in any other position, if it's in off or on, moving this guard back to closed puts it in the armed position, which is where it needs to be most of the time. So that's what the guard does. The emergency lighting, so all of it, is powered by dedicated emergency power supplies throughout the cabin. These are located behind the ceiling panels at the forward and aft entry area, and also usually about 4, I think on the 900s and longer body aircraft there might be 5 on each side of the cabin, behind the cabin wall near the floor, and the photo there is shown one at the floor. Their exact positions are marked by a battery symbol on the panel, which you can see up there. The power supplies, they're just basically several D cells wrapped together with a charger. That's all they are. I've labelled one up there. Each pack powers several different lights or groups of lights, and if you're in there, you can trace what they are by the yellow tags on each cable. and each cable's got its own fuse protecting those lights, and that will allow most of the lighting to continue to illuminate if one particular circuit or light is faulty. So again, it's all done with safety and redundancy in mind. The charging power for these, so it actually comes from the 28 volt DC bus 1. The packs take about 90 minutes to charge from empty, but when charged they'll give you a minimum of 10 minutes emergency lighting, which should be more than sufficient for an evacuation. Now the emergency lighting system will automatically activate if the 28 volt DC bus 1 power drops to less than 12 volts and the switch is armed. It's therefore important that the switch is set off during the secure procedure to prevent the emergency lighting batteries from discharging when the aircraft is unpowered overnight, because the 28 volt DC bus 1 will unpower overnight when you just go on to when you switch the batteries off. So this step in the secure checklist is important. Now, in addition to the flight deck switch, which is really the only one we've spoken about at the moment for emergency exit lights, again, for some of you this might be news, but there is an emergency override switch on the aft attendance panel, and this will switch the emergency exit light on regardless of the position of the switch in the flight deck. I say this is only on the aft attendance panel, not the forward attendance panel, because I guess the assumption is that they will be in contact with the flight deck, or could be in easy contact. But at the aft station, the cabin crew can put the emergency exit lights on themselves, and that will override your switch in the flight deck. Okay, now I'm just going to take you through a little table which is actually in the maintenance manual, but it's quite useful for us to see. So it's a kind of a summary of the emergency exit lights operation and battery pack charging logic. So we've got a table here which I'm going to build up over the next few slides, and what this is saying, so the left hand column is the position of the flight deck switch, so it's either armed, on or off. Then you've got the master caution not armed lights, which are normally off with the switch in armed. If it's not armed, if it's on or off, that light will be on. This is the switch. This is the light next to the switch in the flight deck. The aft attendant panel switch is in the normal position, so that they're not switching the lights on unilaterally, and you can see that in column 4 the emergency exit lights will only be on when the flight deck switch is on. This all assumes that the 28 volt DC bus is providing more than 12 volts, and the battery packs will discharge when the emergency exit lights are on. When the emergency exit lights are off, with the switch in either the armed or the off position, the packs will charge if they need to. So that's what that particular part of this table is saying. All right, let's add the next layer, and this is the difference here is that the aft attendant panel switch is on, and you can see that this will switch the emergency exit lights on regardless of the position of the switch in the flight deck. So they're on, regardless of flight deck switch, the lights will be on and the battery packs will discharge. The final bit of the table is the situation where the 28 volt DC bus has dropped below 12 volts. So all of this is with the 20 volt DC bus below 12 volts, it's not powered. Now, if the flight deck switch is in the arm position, the emergency exit lights will automatically come on with that loss of power, which again might be something that we, as pilots have forgotten, but it's there in the FCOMs. It will come on. The packs cannot charge if the 28 volt DC bus drops below 12 volts, which is the logic there, and obviously they will be discharging whenever the lights are on. The whole table looks like that. I say engineers, you'll find it in the AMM. for pilots is quite a useful little summary of the logic. Okay, for the door exit signs, they've all doors have got signs which illuminate with the emergency lighting system. These signs are usually low, like this, because the assumption is that if the cabin's filled with smoke, you may want to be down on the floor, crawling towards the door to find your way out, where because of the smoke will rise, so the air will be clear below it. Default language of these signs is English, but the operator can have an additional choice of language if they wish. All overwing exits have also got signs which illuminate with the emergency exit lighting system, and you can see they've got these at various levels. And in the emergency aisle area, there are lights in the bullnose ceiling panels throughout the cabin, and these illuminate with the emergency exit lighting system, or the emergency lighting system. And you can see 3 of them are on in this particular photo. Now, as regards floor proximity lights, this again is designed for a smoke-filled cabin. So you've got a floor proximity light system with additional lights installed in the lavs, galleys, closets within the passenger compartment, which provides emergency evacuation guidance when all sources of illumination greater than 4 feet above the floor area are totally obscured, again by smoke. 2 emergency escape path lighting systems are available. You've got the floor mounted photoluminescent strips, which are shown in this photo, or you've got the seat and monument mounted incandescent lights, which are the old system, where you've got lights similar to those ones on the bullnose. Now the photoluminescent strips are charged by passenger cabin lights, and they provide better reliability and maintainability because they don't require wiring or batteries. They are simply just strips fixed into the floor. There is nothing behind these strips. There is no power source, and they glow green when the cabin is dark, as you can see from the photo. So, as I say, these strips they're unpowered. There's no wires or batteries or anything to them. They're just unpowered. Bit like the luminous dials on a watch. There's no power to them. They charge, if that's the right word, and it isn't really the right word, by ambient light, which causes them to glow. The light causes the radioactive particles in them to excite and emit light. So it's not really charging. It's a different process, but it's easier to think of it that way. Now, the longer they've been exposed to light, the longer they'll continue to glow. Now, it's assumed that the strips will have been in darkness overnight, causing them to lose their glow. I'm using this word for a lack of any other words. In other words, they won't be giving off that green colour that you need. Now, in that state, they can't be used for emergency lighting. If they're not glowing, they can't be used for emergency lighting. Remember, you can't just switch these things on or off. There is no on or off switch for these. So, tables are provided in the FCOM System Description Chapter 1 for you to calculate the maximum duration of flight after the cabin ceiling and sidewall lights have been on at full intensity, with the overhead bins closed. That's so that you don't get shadows off the overhead bins, and only minor aisle traffic, you haven't got the aisle full of people, which again are casting shadows onto these. And these tables are actually quite elaborate, and it depends on whether strips are blue or not, or standard width or not, whether you've got sky interior lighting or not, whether the bins have been open or not, whether you've got people in the cabin or not. So you can make this quite difficult, but really you just need to have a ballpark figure in your mind. And what I would say is that for standard strips, you can do a 4.25-hour flight after just 5 minutes exposure to lights with the bins closed and not many people in the aisle. So really 5 minutes and you're kind of good to go. On longer flights, give it 15 minutes. And to be honest, once you're in flight, these will charge up anyway, you know, from the ambient light in the cabin. Again, unless it's a night flight. But the table's there. You should use it. You know, consult your airline policy on how to use it. But the purpose of me mentioning it here is for those people who may not be familiar with it, or have perhaps forgotten, or their airlines don't direct them to use it. But so it's just to give you the knowledge of the existence of these tables. Continuing emergency exit lights, but now looking outside the aircraft. You've got a light after each emergency exit. They shine down and forward to illuminate the exit area. So that's one on a door. These are the overwings. Again, they're shining down and forward to illuminate the exit area. And there's also a light illuminating the trailing edge flap area in case passengers use them to slide off the wings as per the safety instructions card. And this, of course, is why we set flaps 40 in the event of a potential evacuation. So there's the light to assist the passengers. Okay, quick word about circuit breakers. We'll finish off with this. P18 panel has got most of the exterior and passenger cabin lighting circuit breakers. It's P18-3 for what it's worth, and you can see them all up there, including the emergency lighting up toward the top left, passenger cabin on the left, exterior lighting on the right, and signs and the like further below. P6 panel has got most of the flight deck lighting circuit breakers. And the electronic panel has got its own circuit breakers there for the forward and aft electronic panels. More circuit breakers can be found near the rudder pedal adjusters. The captain's ones, that's P41 panel. It's got circuit breakers for the MCP, and the captain's panel lighting and centre panel lighting. Behind the FO's rudder pedal adjuster is the FO's lighted module, so that's a circuit breakers for the emergency and the FO's panel lighting. So if any of your panel lighting goes off, and your feet haven't been, you know, or your feet have been near the rudder pedal adjustment, might be worth just checking to make sure that you haven't accidentally popped out a circuit breaker. I mean, it's realistic. I've never done this or seen it done, or to be honest, I've never heard of it being done. But really, it's probably only the far left or right circuit breakers that you could possibly do it with. You're not likely to accidentally pop the middle ones. Not with your feet anyway, but there we go. Galley lights, the switches and the circuit breakers are usually located together. Again, it depends on the particular galley fit you've got, what they look like, but this is a typical arrangement. So that's it. That is everything I know about lights. Hope you managed to pick up some useful bits of information from this. As always, if you enjoyed the video, please give it a like, subscribe to my channel if you haven't already done so, and share it. If you're feeling particularly benevolent or want more info, get a copy of the book. It's available in print or electronic format from the Apple bookstore. Thanks everyone for watching.